Hey y'all, in this lesson, I'm going to teach you how to simplify radicals with a negative under the square root, or simplify radicals with imaginary numbers. We already know that we can take square roots of numbers, perfect squares, because one of the two equal factors gets to come out. So square root of 1 is 1, because 1 times 1 is 1. That's hard to say. Square root of 4 is 2, because 2 times 2 is 4, and so on. But if I were to try to tell you to simplify square root of -1, well, if you try to do -1 times -1, that's +1. And if you try to do -1 times +1, that's not two equal factors. So we're left with this like big question mark. What are we supposed to do here? So this is where imaginary numbers come into play, which if you thought math wasn't bad enough, now we have imaginary numbers. No, I'm just kidding. It's really not that bad. It's not as scary as you think. So by definition, the square root of -1 is I, lowercase, kind of cursive, italic I. And that way we can simplify these radicals. We can break these radicals down with this definition. And we also have some properties that we've looked at before, where the square root of a times b is equal to the square root of a times square root of b. And this one I added in because I forgot it in the notes. So make sure you add this to your notes if you're using the same ones. The square root of a squared is a, because one of the two equal factors is a. So we're going to use those two properties to simplify the square root of -25. So you're like, you might be looking at this and be like, oh, if it were just positive, I could pull out a 5. Well, now we can still do that because we have this new definition that the square root of -1 is I. So if I break this up and I say -1 times 25, and then I use my properties, square root of -1, square root of 25, I know that the square root of -1 by definition is I, and the square root of 25 is 5. And I should have written that the other way, but it's fine. Commutative property saves us. I5 is kind of weird to say, so we usually write this 5I. And I'm only focusing on the principal square root. So principal square root means the positive square root. And I did this in my previous lesson too, with this definition. A here, we're just focusing on the positive for these. When you're solving equations with radicals, you have to consider the positive and the negative because we're talking about solutions. But for the sake of just simplifying radicals, we're just going to focus on the principal square root, which is the positive square root. So sorry, I should have clarified that earlier and in my previous lesson, but if you were wondering, there it is. Okay, so when they're perfect squares, it's nice and easy, and you can simplify these three probably pretty quickly in your head. So go ahead and try it. Pause it, try it, come back. For these, you should have gotten 7I, 6I, and 9I. And that's all. That's all you have to do. So as I promised, imaginary numbers are not as scary as you think. It just means when there's a negative under the square root, you pull out an I. That's all. Not like an I, but you know, that was a dumb joke. Okay, square root of -50, we're still going to approach this the same way as we would any normal square root. It is a normal square root. It's just we have a negative under there. So we're going to break this up into 50 times -1, and then square root 50, square root -1. And now we have that positive number that we really need to help us simplify. I'm going to use perfect squares. Square root 25, square root 2, square root -1. Okay, and then I'm going to reorder this because in a minute it'll help make sense. I'm going to do square root 25, square root -1, square root 2. The reason I did that, you might be going, this is nonsensical. Why did you do that? The reason I did that is because square root 25, that's a perfect square. Square root -1, I know is I, but square root 2, I know is prime, so it's going to be left alone. So I just changed the order. It really doesn't matter, but I just like things to be in order that way. So I end up with square root 25 is 5, square root -1 is I, Square root 2 is just square root 2. And that's your answer. That's all it is. So it's exactly similar to the previous lesson where we found the square root of 50 was 5 root 2. But now we just have that negative under it. So now there's just an I. And you want to make sure that this I would recommend writing it in front of the square root, because a lot of times if you write it like this, especially if you're typing it into like a homework system, 9 times out of 10, I would say the square root accidentally gets carried over and that I ends up being under the square root, which is incorrect. So if you're typing it in, you want to make sure that you hit the right arrow on your calculator to get out of the square root. I'll show you. Trust me, it's always an issue. Always an issue. So that's why I recommend pulling it out in the front as opposed to the back. So like, there is an I on here. Let me find it. Okay, I see it. So if I type in, let's pretend like this is a homework system. 5 square root 2, and then I pull in that I. I've typed it in, the calculator did what I asked it to do. So I'm just showing you this because if you're typing it into your homework system and you get it wrong and you're like, I know this is right, this is why. So the correct way is, see how I'm done with the square root. So I'm going to hit the right arrow to get out of the square root. And then you can type your I, and that would be correct. So if you typed that into the homework system instead of 5I root 2, that is correct. But when the I is under the square root, that is incorrect. So just be very careful about that. You have to be very detail oriented. All right, try this one, pause it, try it, come back. This one breaks up into 18 times -1. 18 can be 9 times 2 times -1. And then I reordered, I shuffled a little bit, use that commutative property, and we end up with 3I square root 2. And again, you can put that I at the end, just make sure you've closed that square root, and that's it. That's how it simplifies. That's all you have to do. On this last example, I have one where it's a scenario where you might see on a homework where you're simplifying with the quadratic formula. So you've done the whole quadratic formula and you've come down to this very last step where you have 2 plus or minus square root -75 over 3. So you would just simplify it normally. No reason to get stressed or upset. The square root of -75, we can simplify that specifically times -1. That's 25 times 3 times -1. That got messy. I'll fix that. There we go. 25. So that's going to be 5I square root 3. Square root of 25 is 5. Square root of -1 is I. 3 is prime, stays under. So square root -75 simplifies to this. And we have 2 plus or minus 5I root 3 over 3. And then remember, if these all divide by the same number, you can go ahead and divide that. And like I said in a previous lesson, some homeworks want you to break this up into 2 fractions. And that process can help you simplify also. But all of these numbers are prime, 2, 5, and 3, so nothing's going to simplify. So this answer is fine, or this answer is fine. They equal the same thing, so it's okay. We have our 2 solutions, 2/3 plus 5I root 3 over 3, what a mess, and 2/3 minus 5I root 3 all over 3. So that's how you would do that. That's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help, and I'll see you in the next one.